Alrighty, let's talk about braids some more. I like braids. You like braids. Braids. This is, of course, KBF24 at Knots Braids Fall 24 at number 4. Oh, the last introductory video on knots and braids. Then we got to move on to a new series. There's 3 other videos in this series. If you haven't seen them, you don't need to, but if you're struggling with this one, that would definitely help you understand what's going on. Braid properties. We're talking about a really cool mathematical object today called the braid. Braids are exactly the sort of braid that you're thinking of if you're used to making hair into braids, but they also have a number of different interesting properties that we can describe in mathematics. And today I'm going to try and do that again for you. So first off, braids have several different properties. Here are 3 essential ones. And these are, in fact, not only essential properties for braids, but for an entire class of mathematical object called a group. Here are 3 essential ones. The first one is the one that I think is hardest to describe, so I guess it makes sense to start out with it. The basic idea is that each combination, each summation of braids, each summation of braids it can be done in like any order, if that kind of makes sense. So once you've lined up a particular summation, the particular order of that summation doesn't matter. The best example for this with braids, I think, is to do something like what I am attempting right now with the help of my example. Perfection. So these are 3 different braids, and basically what I can do is I can add them in different ways and I'll get slightly different braid configurations. And what you can do is you can check visually and try and make sure that no matter which way I had added them, I would have ended up with the exact same thing. That's the basic principle, the basic idea that we're trying to explore here. So that should be the result of that first addition. This is just the same braid once again. Throw my other addition in there. The overall claim is then that this braid over here, if we add them all together, is equivalent to that braid. That should to you hopefully just look like a simple braid summation. Additionally, though, it means that we can go back and forth. That this braid over here is equivalent to these 2 braids coming together. And that's a bit of a stronger claim. So next up, we can add this final braid on, but as opposed to doing it all at once, we can do it as a section, as though we were adding just these 2 parts of the braid together. Nicely done. So classic goof up there. The beauty of markers. This is why I like whiteboards. What do we do now? Blather. Okay, so my aim is to add this guy and this guy. This is just a pre-step. I didn't make a mistake. I'm just like I just need to do an additional step here that I didn't previously want to do, and that makes this equal sign wrong. But other than that, totally legitimate. Just being very calm here, very patient. I'm a nice guy. This is why I was looking at the paper. The piece of paper is right over there. It's like, it'll help me out. Just keep looking at the notes I wrote earlier. Did I do that? Nope. So, this should hopefully be obviously equivalent to that. Let's just remove this whole thing out of the equation and not hurt anybody's brains with it. Makes my whole note look a little more ugly. But now, the overall claim here, guys, that I've been trying to make is that if I add this onto this, I get the same mathematical object as this, and I get the same mathematical object as that. If you're curious, and this time I will just, the whole thing should obviously add together into, please don't mess this up, So far, so good. Hey, I didn't say be beautiful. I just said don't mess it up. Into that. So these 4 different objects, A, B, C, and D, are all equivalent. And this tells us interesting things about the order in which they can be done. So I can rearrange any of these steps, and that's the basic braid property that we can. That's the basic way that we can express this particular property in braids. If you already know this property in math, this is probably really frustrating. It's like, why aren't you telling us? I was like, I'll tell you later. I'll tell you later. If you're new to this, then hopefully you're starting to get a basic grasp on the different ways in which we can use mathematical representations to approach all sorts of different objects that you've been totally unfamiliar with in terms of mathematical breakdowns. The second piece of the puzzle, the second essential characteristic for braids, and the third are fortunately things that we have just covered. Ultimately, that identity property is key. Our ability to add braids together like so. It just results in the original crossing. And even if I take some other identity fragment and I add it on the other side of it, what I'm expressing that's slightly different this time, guys, is just the siding, right? These sides and the relationship to the equal signs suddenly is starting to matter. And that's the level, we're starting to dig into the level of mathematics where things like the equal sign and the addition sign are actually standing in for really quite precise mathematical concepts. So this is actually supposed to be a composition, and then this, I believe, is some sort of crazy equivalence relation. All of these different pieces have very specific pieces of meaning in mathematics, and I'm just trying to give you these cool, interesting little objects that we can use to try and explore some of those consequences without getting too deep into the nitty-gritty of it all. Again, one cool piece of braids and of identity braids is that the identity braid can exist on 1, it can exist on 2, it can exist on 3, it can exist on an infinite. Put an extra dot there. It can exist on an infinite number of strands, and that's really cool, right? You got a never ending, ever expanding identity braid. Last but not least, let's do inverses. Let's do a slightly different example from last time. Close enough. Take this braid, I hold it up to a mirror like so. I add one section of it onto the other. Oh, yeah, close enough. I went a little too deep with that. Forgive me. And if we put these guys together, we should see that this guy comes over, this guy comes all the way under the top, and it all just unravels into the identity braid. So, if you want a review on these two guys, check out the previous video. If you're struggling with this, just keep looking at and trying different braid additions. This is a really good simple braid addition. Now, you'll notice that actually cutting apart braids is in theory possible, but in practice, it looks like a real challenge. We will perhaps come back to braids when we've done a better treatment of the mathematical objects to which they belong called groups. For now, thank you so much for being here, and take care of yourself. Have a great day.